Hello, everyone. Today I'm going to talk about disjoint events and independent events. These are two important concepts in Introduction to Probability, but I found many people were confused by these two concepts. So let's start with disjoint events. Sometimes we call them mutually exclusive events. So we say A and B are mutually exclusive or disjoint if the intersection of A and B is empty set. So the probability of the intersection would be 0. Now, what is the independent event? So we say if events A and B are independent, if knowing one happens or not doesn't affect the probability of the other. So if we use the conditional probability of A given B is just the probability of A. So knowing B is redundant. The information is useless for finding the probability of A. And similarly, the probability of B given A is the probability of B. Another way of saying that is the probability of A intersect with B is the product of the probabilities. You can use the product rule of probability to show the equivalence of all three, assuming neither probability is 0. Let's have a look at an example. So you toss a fair coin twice independently. So the results of one toss would not affect or be affected by the result of the other toss. Let's look at the probability that the first toss yields an H is heads, and the second toss yields an H, heads. And the probability would be 1/4, which is half times half. And notice that it's not 0. Okay, this isn't one confusing part of independence. Usually people assume that if A and B are independent, then the probability of intersection is 0. Actually, it's not. In fact, assuming neither probability is 0, then the probability of the intersection is never 0 if A and B are independent. Now, of course, logically, it's not equivalent to the other way around. So if the probability of the intersection is not 0, it doesn't really mean they're independent. Okay, there's something also you would like to be aware of. Let's go back to the disjoint events. So if A and B are disjoint, what is the probability of A conditioning on B? Say you select a ball from an urn that contains several black and white balls. Let's call B the black and A the white. Now, if you tell me that the ball you selected is black, what will it be possible that it is white? Well, it's not. So the probability of A given B is 0 if A and B are disjoint. We actually can prove it by the definition of a conditional probability using the fact that the probability of the intersection is 0 if A and B are disjoint. But I would like you to use the common sense to figure this out. This is a table that lists some of the important facts about these two concepts. That is for today. Thank you. Bye-bye.